buttons. Oh, recording in progress. Oh, hey, she's nice. Right, Tumaini, Genesis, hello. Hello. Hi, welcome, welcome. And I hope your day at school was good. And what we're going to do today is more moles. We are going to look at the questions which I sent last time. We are going to see which chemical questions you can do. And when we find what level you are, we will concentrate on those. I have a little bit of experiment to show you right in a few minutes, and then I have another experiment to show you towards the end. The one at the end is, I hope, quite interesting. We'll see. So what we're going to do is I'm going to share my screen. I'm going to show you some work which we should have done last time, I hope. Oops, where's that gone? Here, I hope we can see that. Can we see that, Yasin? Yeah, good, excellent. Oh, thanks, Di. That's a star of you. Okay, Tumaini, Genesis. I'm going to ask you whether you could do number 1 and 2, and then I'm going to ask you whether you could do 3 and 4, okay? I'm going to tell you the answers, just in case you haven't had them, but the answers in the answers to these ones are, for the first one is 74, okay, for RMM of COH2 is 74, and I'm going to ask you about CuSO4, and the number of moles in 2 grams of CaCO3 is 0.02 moles. I will ask you about that one, okay? So I'm going to ask you for a thumbs up for 1 and 2, and then for 3 and 4. Okay, so I'm stopping sharing. So, Tumaini, Genesis, we need thumbs, please. Question 1 and 2, which was calculating RMM. Are we okay or not okay? Genesis? Hello, Genesis. Hello, Genesis. Are we okay with question 1 and 2? Excellent. Tumaini, are we okay with 1 and 2? Or not okay with 1 and 2? We're okay, that's good. Okay, so who has an answer for the RMM of CuSO4? Question 2, the RMM of CuSO4, copper sulfate. Who has an answer for that? Anybody at Genesis? Anybody at Tumaini? Dan, if you want to just turn the microphone on and get an answer, that's fine. Oh, we're getting a sign from Michael. Oh, where's that? Oh, that, yes, no. Okay, for question 1, it's not 58 because they have forgotten to double the oxygen. Okay, they have forgotten to double the oxygen. It's nearly right, but not quite. Okay, anybody at Tumaini? Question 1. Question 1. The answer is 74. Very good. Well done. Who's that? Who's got that number 74 there? That's very good. Anne. Well done, Anne. You are going to be a rocket scientist. Well done. Okay. So question 2. I'm just going to go through. I'm just going to show. Oh, let me see that again, please, Michael. See that one again, please, Michael. Where is it? CuSO4. Down a bit, please. Down, sorry, if you lift your page up a little bit, down, up a bit more, bit more. Slide the page up again, or the camera down a bit. I want to see the CuSO4. You've got the. Oh, there's a bit missing. I can't move your page up. Anyway, we'll go back. What's the answer? 89, does that say? Anyway, we'll look at it. Okay, let's just make sure we can do this. So what we're going to do is I'm going to go back to sharing. Oh, gosh, yes. Okay, 0.02 moles. Well done, somebody in Tumaini. Let's go back, though. Let's just make sure we can do these ones because these are very important. Okay, so here we go. The only complicated thing in this first one here, here, is that we need to, hang on, let me just change my color. We need to count up all of the atoms. I have 1 calcium, and that weighs 40. And then I have here, it looks like I have 1 oxygen, but this 2 here means 2 of the whole of the OH. So I have 2 oxygens and they are 16 each. And then I have 2 of the hydrogens, which are 1 each. And that is 40 and 32 and 2, which I think is still 74. I hope so. Okay, with CuSO4, Cu, it depends on your periodic table, but some periodic tables show it as 63, some are 64. It's actually 63.5. And then there's 1 sulfur, which is 32. And then 4 of the oxygens. Whoops, hello, that's rubbish writing. My apologies. Let me just, come on. Let me just get rid of that. There we are. So 4 16s, and that should equal 159.5. This one is happier there. Good, excellent. Now let's go back to last time we had a lesson, and you may. Oops, hello. I've just dropped. Oh no, hang on. Sorry, I've just unconnected myself. Now there we are. Sorry, I may have gone dark there for a minute. I hope I've come back. Am I there, Di?
Yeah, you're there. You're there.
Excellent. Now, you may remember this person from last time.
Excuse me.
Hello?
Excuse me.
Hello?
Can you round off the RMM of copper?
If you're, what you should do is you should look at what the periodic table you have been given in an exam says. If it said it is 63, then that's okay. If it says it's 64, then that's okay. But if it says, and this is correct, that it is 63.5, you should not round it. You should just leave it. With all of these, for RMM, the number should not be rounded. Okay? That's really quite important. The reason copper does not have an integer, a whole number, good, thank you, is because it has isomers, isotopes. And we will look at isotopes another time if we need to. Okay, so in the second example, that's question 3 and 4, you may remember this person. And you may remember that we had a way of trying to remember the triangle that relates mass and moles and RMM or RAM. And in the second the second set of questions, question 3 and 4, we have to use that triangle. So somebody in Tumaini has already shown me that it's 0.02, which is excellent. And I will just show you very briefly how we do that again. So here we go. Oh, back off that. I don't want that. I want this. Okay. So our triangle, and it's really important that we can remember our triangle. It's a rather stupid triangle, I know, but the triangle has to be remembered. And if you remember, that animal, the mole, and we say moles, is at the bottom of the triangle, and because they ram underground. Now that's not ground, that's mass, obviously. And this is RAM or RMM, depending on whether we have an atom or a molecule. So all I have to do, if you remember, is to cover up the bit that I want. So in my question here, it says how many moles. So I'm going to use moles here. And I would show the examiner, I would show that I know how to do it. I would go, hey, moles equals grams over RMM. It's an M because it's CaCO3. And that is 2.00 grams, no rounding, over. And when I add this up, it is 100. And 2 over 100 is 0.02 moles. In the second question, in the second part of the question, question 4, we have to turn the kilograms into grams, because it is still true that moles is grams, not kilograms, over RMM. So that would be 2 1,000 grams over the mass of water, which is 18, the RMM of that, which is 18. And I will come back and I will ask you what the answer is. So let's see who's got the right answer here. Oh, my screen, sorry, my stand is broken. I've just broken my stand. Right, who has the answer to how many moles in 2 kilograms of water? That's the same as 2 liters of water. Anybody got the answer? Come on, Genesis. Tumaini got the first one right. Can somebody from Genesis tell me how many moles? Come on in. I'm looking at, ooh, what does that say? That's question 3. That's very good for question 3. Well done. Yes. What about question 4? The water. A little bit further down, I think. It looks like 111.1. Yes, excellent. Who is that student? That student goes straight to the top of the class and has a soft cushion for their chair. That's very good. Well done. Tumaini. The answer is 111.1. 111.1. Did we get that? Dan? Yes, excellent. Well done. Brilliant. Okay, that's very good. Well done. I'm really pleased. If you can do those two bits on their own, doing the RMM and working out the number of moles is really powerful. Oh, Silver Spring. Hello, welcome. Welcome. We have just been looking. Hi, nice to see you, Silver Spring. I don't know whether Fatma is there with you, but we have just done question 1, 2, 3, and 4 from last time. I will give you the answers now. I have recorded this so you can see how to do it, but I'll just give you the answers now. So if you're ready, just in case. So the answer to number 1, the questions which you should have had last time. The answer to number 1 is 74. Number 2 is 159.5, 159.5. The answer to number 3 is 0.02 moles. And to number 4 is 111.1, 111.1. If you want to look at this afterwards to see how to do it, I will have recorded it and you will be able to see it. Now we go on to empirical formula. And I want to show you something to explain why empirical formula is important. Empirical formula is important because of something that I'm going to show you now. So here we go. You will need to watch. Some of you will have seen this before. These two chemicals here, they look like water. I'm not going to drink them because this one is toxic. This one would kill me. This one would not kill me, but this one would make me, this would make me very red in the face. I'm pretty red anyway, not as red as your jumper, Genesis, but I am quite red. But I want you to watch what happens here because this is very peculiar. Now, what this is this is lead nitrate. This is potassium iodide. What I want you to do is to watch what happens when I add it. So 2, like water, I add them together. Okay, here we go. I add it and the product, it is quite difficult to understand this. When you get water and you add it together, if it did this, you would be, this is weird. This is juju. This is chemistry. This is lead nitrate, and you may be able to see it is settling out at the bottom. It's very dense. It settles out at the bottom, and after a while, I'll leave it and then I will show you again. But this is lead nitrate. Now, is lead nitrate PBI, PBI2, PBI3, PBI4? Don't know. So this is what empirical formula is to find out. It is to find out what the formula of that is, because that's very important. Chemistry is about trying to make things which are useful. So let's say I have a headache, I want to make aspirin or paracetamol or something, okay? I need to know how much to add, how much of this chemical, that chemical, and to do that, I need to know about the formula of the final chemical. So this stuff here, lead iodide, what I'm going to do is I'm going to show you how we do the calculation. so that we can see it, but I want everybody to be able to do it without any trouble. Okay, so I'm going to show you it. If you can already do empirical formula, no problem. But I'm going to show you it now. Okay, hopefully. Whoops. Okay. Okay. So we use oh hello, what's happening here? My pens are not working. Ah, right. Ah, come on, get out of here. Okay. So we are using the triangle, the moles are underground. And what I'm going to do is I'm going to set you a question and I'm going to show you how to do it. Okay. So I'm going to say 2.07 grams of lead. Now lead is PB. It is from the Latin, which is an old Italian language. And its name was plum bum, which is quite funny. This reacts with iodine. And iodine is I. And it reacts with iodine to form, and this is quite a difficult question in some ways, 4.61 grams of lead iodide. The question is, what is the formula? Whoops, formula. Now, what we're doing here is we are trying to find out how many moles of lead react with how many moles of iodine. So if I had lead and I had iodine, I'm not going to make it I2 at the moment, and it forms lead iodide. It could be PBI, it could be PBI2, it could be PB2I3, I don't know. So what I'm trying to do is to find out which one it is. So first, what I do is I say, okay, if lead iodide, whoops, sorry, hang on. If lead iodide is 4.61 grams and the lead is 2.07 grams, these came from the question. Look, 4.61, 4.61. 2.07, 2.07. So they came from the question, okay? So what I'm doing now is I'm going to find out how much iodine I have. So I'm going to take this away. So the iodine is 4.61 minus 2.07, which is 2.54, as long as my head is working. Di, you're a mathematician. I have done that in my head, but I think it's right. Okay, so now I know that I have 4.61 grams of PB and 2.54 grams of iodine. But there's a problem. And the problem with this is that iodine atoms weigh different from lead atoms. So what I do is this. I construct my answer like this. I tend to do it in a long line like this. In the first, I put the element. In the second, I put the percent or the grams. Sometimes they give you a percent, sometimes a grams. Then I work out the moles, and that will be the percent over the RAM. And then I divide by the smallest. So in this case here, now I have lead, and in my lead up there, I know I had 2.07 grams. When I look on the periodic table, I find that lead, its RAM is 2.07. This is why I picked this number. I know that my iodine is 2.54 grams. And I know that the RAM of iodine is 127. So what I do then is I work out moles, and moles, we know moles are underground. Yes, the moles are underground. Moles, there's RAM or RMM underground, right? So I want the moles. So that's grams over RAM. So I do in this one for the lead, I go 2.07 divided by 207. And that is going to be equal to 0.01. And then I do my iodine, and I have 2.54. That's the mass of the iodine over, sorry, my computer suddenly turned off. That's a bit weird for me anyway. Oh, there we are. Over 127, and that is equal to 0.02. Now, what I want to do in this bit here is I want to try and find the ratio. If I have two numbers and I look at these two, then I find the smaller one, 0.01, and I divide it by itself, obviously to produce 1. Now I take this number, 0.02, and I divide it by still the smaller number, which is the 0.01, and that is 2. Now that means my ratio shows that I have lead, and I just have one of those, and I have iodine, but I have 2. And you know that here I don't need this 1, so I can just write PbI2. Okay? So these are the steps we will go through. We will do another one in just a minute, but that's the steps that I suggest. All right, so it's pretty simple. Each time we list, firstly, we list the element. Whoops, sorry, wrong. Don't do that. First things we do is we find the element. We write down the elements. Then what we do is we try to find the percentage or the grams, which is in the question, okay? Then what we do is we find the moles. And the moles is always the percentage or the grams over the RAM for each one of them, okay? And that will give me a ratio, but sometimes these numbers are not very good to look at. So we do this, divide by the smallest to produce these two numbers here. And then we go, okay, now I know that the lead here is 1 and the iodine here is 2. Okay, let's stop sharing. Now, I hope, I keep on pulling the lead out of this thing. Right, I hope the method made some sense there. If the method makes sense, then we will be able to do the calculation of empirical formula. Empirical formula is very simple. It is just the simplest formula. So PbI2, it's 1 to 2. It's very simple. Maybe it's Pb2I4, but for the moment, we're not going to worry about that. So we're looking for the simplest ratio that we can. Okay. So what I'm going to do is I'm going to see whether you have managed to do these. So I'm going to share the screen. I'm going to go back to the sheet of questions and hopefully, whoops, where's that gone? Here. It's these questions here, okay? So this is it. This is calculation of empirical formulae. And it was this one here, number 1 and number 2. If you did number 3 and 4, that's fantastic. But 1 and 2, let's see if anybody managed to do already 1 and 2. If you did not, don't worry, we'll have a look at one in just a minute. So let's see if anybody from the Schools of Hope could do this. So do I have anybody from Genesis to Miami or Silver Spring, who could tell me the formula for the silver and sulfur. Let me just, excuse me, let me just try and pin you there, Michael, so I can see it because it's a bit small. Wow, you guys, that is really good. Oh, I see. Was question 2 just too easy, was it? That's really good. Ag2S and SO3. Who was this, please? Michael, who is that? Because I think that's really great. Oh, it's Anne again. Well, Anne, what a person. Anne, you are going top of the list again. I'm really impressed. Well done. Okay, that's very good. If I've got somebody else, oh, we've got somebody else, Michael. Sorry, let me just have a look. Ooh, NCL, yes, NCL3 as well. I tell you what, Anne is a bit of a genius. That's really good. Well done. Okay, so I'm going to just remove the pin and go back to the joke. No, let's have a look from everybody else. Let's see if anybody else has managed to do this. So Anne there said that the first answer to number 1, number 1 was Ag2S. Ag2S. And Anne is right. She said the second one was NCL3, which is also correct. And then she said it was SO3, which is correct. Now, let me just check. So, Michael, do the people at Genesis feel okay about empirical formulae? Genesis people, Genesis, hello, Genesis. Are you okay about empirical formula? Excellent. Silver Spring, are you okay about empirical formula or no? Yes or no? That's a no. Okay, Tumaini, are you okay about empirical formula or not okay about empirical formula? Okay, Tumaini is okay with it. All right, Silver Spring, I am just going to do one because the other 2 groups can do it. I'm just going to do one and we will see. If you haven't yet done number 4, Tumaini, Genesis, just have a go at that. But I'm just going to show I'm going to just show Silver Spring 1. Okay, just 1. Okay, so here we go. All right. I will do the one with sulfur and oxygen. I will show you how to do it. I'm not actually going to do it. Okay, so I'll show you and then you can work away at that one. So if you remember, we set up the question, the system like this, very long, whoops, hello, very long lines like this. We put the elements in the first, so it says it's got sulfur, S, and it tells me I've got O, oxygen. It tells me in percent that I have 40% of sulfur and 60% of oxygen. Then I work out moles, and the moles is the percent or the grams, depending on which one you are given, over the RAM. Okay, so this would be then 40 divided by, and you would have to look on the periodic table, but sulfur is 32 and oxygen 60 divided by 16. Now I'll let you do this while we just move on a little bit, so you can work that out, and then you divide both of those answers by the smaller one. I'll just make that a bit bigger, sorry. Okay, so, it's very straightforward arithmetic. So we are looking at, this is, the first one will be 1.25. Okay, you work out this one. Sorry, that's 1.25, my apologies. Okay, so that's 1.25. You work out this, then divide both of these numbers by the smaller one, which will give you 2 numbers. If you have got it right, the numbers will come out as 1 and 3. Okay, all right, so that's how you do it. If you need extra help, you can hang on towards the end and we will do that. Now, we're going to go back. I'm stopping sharing now. I'm going back to stop sharing. Okay, here is the stuff which we produced. And you can probably see that it is starting to settle out. So we have solid at the bottom and it is more liquid at the top now. All right, so the next bit, the next questions. The next questions are on reacting masses calculations. And I'm interested in whether anybody can do the very first one. Genesis, and I guess Professor Anne, or is it Dr. Anne, or Queen Anne perhaps? Have you managed to work out the mass of carbon dioxide formed when I decomposed 200 grams of calcium carbonate? Did you work that out? Genesis, did anybody work that out? Michael, did anybody work it out at Tumaini? Dan, did anybody manage to do that? Quite important if we can. If we manage to do it, that's excellent. Somebody at Tumaini, 88 grams. Wow. Who is that? Well done. It's really good. Well done. Your name, please, sir. And we've got, oh, that's very good. Sharon, well done, Sharon. And well done, Phil. Brilliant. That's really, really good. Okay, that's, okay, Sharon, really good. And well done, Charles. That's brilliant. Fantastic. So let's just have a brief look at how we do these. I'm going to move on from this to something else. We're going to see if we can make it a little bit more complicated. So the answer to number one of the reacting mass calculations, and for those of you who are not very good at this, I'm just going to do one example and I'm going to show you my method for doing it. Okay, so I'm going to show you just this one method and then we will see whether we can do some more. I'm going to set you another one. Okay, so I'm going to set you another calculation, which I hope you will be able to do. So here we go. I'm going to share the screen again. Okay. So this is the question. Here it is. And what I want to do is it says by decomposing 200 grams of calcium carbonate. So I'm only interested really in this equation here. Okay. And the way I do it is I use some boxes which help me construct my ideas. And I use a small box starting with the calcium carbonate. We'll see why in just a minute. And then a much bigger box. And then I have an arrow which goes across, it's got a break in it to the carbon dioxide because that's what we're interested in. And there's a small box here. And then there's another big box. Now, what we have here is a way of thinking about these, about this way of calculating. This here is what we call a quantity. So for instance, grams, okay? So it could be an example is grams. This here is always moles. Then this up here is moles, and this is a quantity. Now, what I mean by quantity is just something that we can measure out. So calcium carbonate, they tell us in the question that it forms by decomposing 200 grams of calcium carbonate. So what I do is I start here with 200 grams. So into my first box, I just write down what I've got of calcium carbonate. It's just the quantity that they tell you. They always tell you in the question one of these. Then we work out moles. Now we know about moles because moles are underground. So grams over RAM or RMM. It's an RMM because this is a molecule. So I have to add this up. And when I add this up, I get 40 and 12 and 3 times 16, which is why I picked it because it's a nice number, 100. So in this case, that is 200 grams over 100, which equals 2 moles. Now, from my equation, I can see that, can't wake up. I can see that one CaCO3 gives one CO2. If there was a different number here in front of the CO2, then that would be different, but it isn't, okay? It isn't anything different. Now I'm going to change my color because what I'm going to do is I'm going to show you the blue was all about calcium carbonate, and now I'm going to go to carbon dioxide. So my ratio is 1 to 1. 1 calcium carbonate gives 1 carbon dioxide. So 2 moles will give 2 moles. That's all we're doing. We're just saying, well, okay, if I've got 2 moles on the left, how many moles on the right? So there we are, 2 moles. Now the quantity, the thing that they ask you is what mass. So the quantity I want is grams. And grams equals moles times RMM. It's an M again because carbon dioxide is a molecule. So the grams equals the number of moles. Now the moles is here, 2. Okay, 2 times. This is 12, and 2 times 16, and that's 44. So it's 44, which equals 88 grams. And that, as seen by Charles, is fantastic. Okay, so that's the method. So I'm going to stop sharing my screen and come, oh, lordy. Sorry, I keep on unplugging the power lead for this. And it's having a bit of an issue today. Okay, so stop sharing. Okay, so that's my method. So 4 boxes, small, big, okay? Arrow linking them across will work for every single moles calculation, every single one of them. And this is really important. So I'm going to set you a question now, and we're going to see whether you can do it while I get some chemicals together for a sort of end of lesson little demonstration. I'm just going to get the chemicals so I can show you them because that's important. How many grams of aluminium was it? Okay. Here I have some aluminium. Okay, it's aluminium powder. And I have 3 grams of aluminium powder. Okay. Here I have some iron oxide. This is rust. Okay, this stuff is rust here, just ordinary rust. This is iron oxide, it is iron 3 oxide. I'm going to write the equation for it. What I'm going to do is I'm going to mix these 2 together. And nothing happens. It is completely safe when it's mixed together. And it still looks like just a mixture. It's not very interesting, okay? When I mix it more, it will be more of a uniform color, but I'm going to do something special with it in just a minute. Okay. It was kept in this funny thing. This is to keep the chemicals dry. This chemical keeps the chemicals dry because the stuff in the bottom is a drying agent. It absorbs the water. So I have this is called an evaporating basin. This is something where we can mix big amounts of chemicals up. Okay.
Mark, they want you to repeat something. There's a chat thing.
Oh, sorry, I missed the chat. Hang on.
Yeah, Silver Springer just asking you to repeat the last part.
Okay. Well, I'm gonna run through what we're doing. Okay.
Okay.
I'm gonna run through. I'm going to write down what we did, Silver Spring. Okay. So I'm gonna share my screen. Come on, share screen. Okay. Okay. So here I have my, come on, I'm happy with that. I have aluminium and I have iron 3 oxide. If you remember, this is the valency of the iron. Now this reacts together because aluminium is more reactive than iron, and the aluminium takes the oxygen away and it forms aluminium oxide and it kicks out the iron. This will balance. There are 2 aluminiums here, so I need 2 over here, and then I make 2 ions. What I want to know is if I start with 3 grams here, this would go in my first small box, then how many grams of iron can I produce? So my calculation will go small box, big box. This is for working out moles. This goes then all the way over here. And the ratio, if you look at the ratio, it's quite simple because it is 2 to 2, which is just the same as 1 to 1. So however many moles there are of aluminium, I will get the same number of moles of iron. And then in this big box down here, you can work out the grams, because grams equals moles times AR. Important, the AR of iron is 56. It is not, we do not worry about this 2, okay? We ignore that. So it is not 112, it's not 112, it's 56. So moles equals grams over AR here. So you work out that here, come across, work out the moles here, and work out the mass here. And I'll give you a moment to do that while I just go and I do a little bit of getting ready, ready for the experiment. So I'll leave that there so you can see it, and then I will come back. I hope that you can see that okay. We only have a little bit of magnesium. Okay, does anybody have an answer? Does anybody have an answer? If I start with 3 grams of aluminium, how many grams I get of iron? Anybody work that out? Michael has, does that say 12.4? You have used, I think you have used 112 at the end for the RAM of the iron. Have you, can I, hang on, I'll just pin you, hang on, let me just. Yes, okay, very, very good, but just one thing wrong. And that is that the RAM of iron is still only 56. We have dealt, basically, we have dealt with the 2 before we got to that point. So we use AR of 56. If you change it from 112 to 56 there, you would have got it right. That's really good. Michael, Genesis is really good. Who else? Has anybody else got the answer? Just before I do the experiment, I'll show you what I'm going to be doing. And hopefully I will be able to talk to you from over there in just a minute. In just a minute, we are going to be looking over here. And you will be able to see here, I hope, a tin. It's like a tin, and in the tin there is some sand, and there is a lot of protection for the desk. And you can see a little white thing in the tin of sand. And I will be going over there in just a minute. Okay, I'll be explaining what we are going to do. So this is to finish the lesson now. I'm going to go over there and I'm going to try and do the experiment, and I hope you will still be able to hear me and everything. I will tell you the answer so you can do it yourself, and we can look at it again next time, but next time we will be going on. The answer is 6.22 grams. 6.22 grams. Work it out for yourself. 6.22. So if you start with 3 grams of aluminium, you get 6.22 grams of iron, which is more. Fantastic. That's because iron weighs more than aluminium. So I'm now going to disappear over there, and I'm going to hope that you will be able to see me and still hear me. You will have to shout out if you can't. Die. You're the master of sounds.
Okay, I'll shout out.
Oh, you like shouting out anyway, Di?
Yeah, yeah.
Right, let's see if we can get.
I like shouting at Yestin.
Well, I like shouting at Yestin.
Everybody likes shouting.
I'm just disappearing over here. Hello. Hello.
Yeah.
Can you hear me, Di?
Yeah, just about.
Okay, I'll shout. All right, in here, I have a little container, and in the container, I have the mixture of the aluminium and the iron oxide. Sometimes this doesn't work. If it doesn't work, I will do it next time, okay? But what I'm going to do is I'm going to use this Bunsen burner, and I'm going to light some magnesium here, which will take the heat down and start the reaction. At least I hope it will. Ah, I've forgotten something, wait. I have forgotten a piece of kit I need for afterwards. Okay, so here we go. So what you will see is you will see a bright white flame, and it will go down, and then if the reaction happens, well, I'm not going to tell you what you will see. I hope you will enjoy it. So I'm going to light this, and then I'm going to get out of the way. Ah. Okay. It has produced, stop. Ah. it has produced some really hot iron. It has broken the container. This was iron which for a moment was molten. That is over 1600 degrees Celsius. So we have made iron, which is quite clever. So the aluminium has taken the oxygen away from the iron and left the iron. And that is really hot. And it is a piece of iron. And it will be 6.22 grams, like you worked out. 6.22 grams of iron. I'll come back over. I got to say, I'm blind. Okay, I hope that was quite good. The heat that is given out, the word is exothermic. You know this, exothermic. It's a reaction which gives out heat, and it is because the aluminium is higher than iron in reactivity, and when it takes away the oxygen from the iron, the aluminium becomes more stable and therefore gives out heat. That, ladies and gentlemen, and the geniuses that are Charles and Anne and all the people in Genesis and Silver Spring and Glory and Tumaini, it's lovely to see you. This is recorded. I will put it onto YouTube and then I will send it to you. So if you missed the beginning, it doesn't matter, but it's lovely to see you. And I hope that was useful. And it is fireworks. Okay. All right. So I'll say bye-bye, everybody. And I hope that was interesting or at least useful. And next time we're not going to do moles anymore for a bit. We will return to moles, but your supervisors have all the answers like this and how to do them for each one of the questions. So if you are stuck, just ask your supervisors. They are geniuses. But now, bye.
He's waving at you.
Just like that.
Just like that. Actually,
Bye-bye, Genesis.
Mark,
Lovely to Tumaini. Lovely to see you. Really great. Thank you very much. Bye-bye, Glory. Bye-bye, Silver Spring. Bye-bye, Dan. Dan,
Mark?
Fiona, yes.
Bye-bye, teacher Mark.
Bye-bye,
You
teacher Mark.
Thank you,
sound like-
Mark. Thank
It's a
you.
pleasure. It's a pleasure, Jean.
That was great.
Thank you, Teacher Mark.
Pleasure, Sophia. Pleasure. Dan, you've got a great career. I love your career. I wish I had teeth like you.
thank you.
Will you sell me? Shilingitano.
You're getting to sound more like Frank Spencer.
Thanks, mate.
Yeah, there was one little part where you said, settled at the bottom.
I don't know. He settled at the bottom. Thanks, Sean. You're always welcome, mate.
No. You're absolutely superb, man.
Yeah.
Well, we got a firework at the end, which is what counts.
You did. But you weren't wearing your protective goggles.
That's
No.
that's why I got out of the way. I said,
Yeah, I know.
I'm getting out of the way. It's not, rust is not dangerous, Sean, unless of course it's on your car.
Hey, you got a message from Silver Springs, Mark.
Just got Silver Spring left here. I'm hoping, yeah, I'm just going to, thank you very much, Di. And let's, oh, where's it gone?
But the whole lesson's been recorded, isn't it?
Yeah.
I could. Silver Spring, are you still there?
Gone.
So, they're frozen, are they?
I think they
Yeah.
have. Silver Spring, if you can reconnect, I can give you a moment.
Yeah, they're there.
Hi,
Oh,
guys.
there.
Hello. Hi. Hey, everybody. Apart from Silver Spring, I'll just hang on with them for a minute. But it's lovely to see you, and thank you very much indeed. for telling me.
Well done, Mark. Well done.
I'll get the top hat and my Frank's.
Just like that.
Frank Spencer, he was definitely.
That was Tommy Cooper.
Hawkins, you're so dead. Right.
Tommy at his best.
You know,
Tommy Cooper.
Tommy
Yeah.
Cooper, for goodness sake.
Lovely to meet you, Sean. Just ignore the banter that happens here. It's
Oh,
nonsense.
it's fascinating. Thank you very much, Mark. That was really interesting. I didn't understand it all, but it was very well conveyed.
I didn't
Even
understand.
Sickos
it.
like me.
Anyway, Thank you. Thank you.
Bye. I should go.
Yeah, cheers, Mark. Take care.
Cheers,
See you
Mark.
guys.
I wanted to introduce you. Sophia, are you there?
Oh.
I'll
Yes, I'm here.
I'll connect up. Just okay. Bye. Thanks, Mark. I'll send you a link, and we'll try and quickly connect
Okay.
up.
Right,
Yeah.
Silver Spring. Hang on just a minute. Right, I'm gonna talk to you just for a minute, Silver Spring. Do you are you at all familiar with moles or not? Familiar, not familiar? Not. Okay. All right. Best way. Okay. Best way is this. I will share my screen. I will show you something that I did last time with everybody else. If you want to turn on your microphone, then we can actually talk, which might be better. But I will do this on the board here. Okay, I hope you can see that. CH4, this is methane. This is natural gas. And when it burns with oxygen to make carbon dioxide and water, okay? And this is a balanced equation, 1, 2, 1, 2, okay? Now, if I turn this into English, like if I write it as a sentence, then I would write something like this. I would write 1 molecule of CH4. This means reacts with, so plus, reacts with two molecules of O2, and it makes, to make, there's only one here, 1 molecule of CO2 and 2 molecules H2O. Okay, so molecule, just one small particle. Is that okay? Yeah. Okay. Now, the mole is just a big number. You know, in a soccer team, there are 11 players. Yeah. If you turn up with 5, you lose. Yeah. So we don't say a soccer team of 11 players. We just say soccer team, and we know there are 11. The mole is just a number. Like soccer team always has to have 11 players, a mole always has to have the same number. Now, what I do is this. I'm going to rewrite this. So I've just changed it just to 1 molecule, 2 molecules, 1 molecule, 2 molecules. Now what I'm going to do is this. I'm going to say, hey, like a team, a soccer team, atoms and molecules have teams too. And their team is called a mole. So what I do is I go, hey, look, this equation tells me 1 mole CH4 plus 2 moles O2 makes 1 mole CO2, like one team of CO2s, and 2 moles H2O. Now, you know that on the periodic table, different atoms have different rams, yeah? Like, you know, hydrogen is 1, oxygen 16, and so on. So if I work out what these weigh, what their RMM is different, isn't it? CH4 is carbon weighs 12, each hydrogen weighs 1, so it's 12, and 4 ones, so it's 16, okay? So this, if I work out RMM, this is 16, this methane. Each oxygen, there are 2 in here, but each one is 32. This is 44, and this is 18. I'm not very clever. I know those numbers. I don't have to do them. I don't have to add them up. I know them. Okay. So what we want to do is to link mass and moles. And the way we do it is this. We use this triangle, which I have used today in the lesson. And the triangle goes like this. Now, what this tells us, I don't know if you can you see that okay? It says moles at the bottom. Oops, sorry, where am I? It's difficult with my finger. Moles here, and then this is RAM or RMM. RAM for atoms, MM for molecules, and at the top is the mass or the grams. And what you do is you just cover the one you want. So if I want to know the number of moles, I just cover it. Moles equals grams over RAM or RMM. If I want to know mass, if I want to know the grams, I just cover this. It equals moles times RAM or RMM. Okay? Our stupid way of remembering it was the mole is that thing which lives underground. You know, that funny little animal. And that, when it goes, it makes a hole. Yeah, it lives in a hole under the ground. And we say it rams. So moles ram underground. It's a stupid way to remember. It's childish. Moles ram underground. So you know G is at the top of the triangle. Okay. So let's see what we do here. So let's say I want to work out, let's say I start with, I'm going to start with something simple, 1.6 grams of methane, and I want to know how much carbon dioxide is made, okay? So I'll show you that now. It's really not very difficult, I promise. So in my question here, I'm going to say, if I start with 1.6 grams here, how many grams of carbon dioxide will I get? Okay, 1.6 here, how much will I get over here? I'll tell you that the answer is going to be 4.4, but we'll look at why. So what we've got to remember is if we were able to say 1 molecule of CH4 gives 1 molecule of CO2, then 1 mole gives 1 mole, okay? 1 team gives 1 team. And therefore, what I need to know is how many moles 1.6 grams is. So I use my 1.6 grams and I put it into this triangle here. I want to find moles, so I go, okay, that's 1.6 grams, so I put it over the RMM. Okay, so here we go. So I go moles. How many moles is this? Moles equals grams over RMM, and that's 1.6 over, I worked it out before, it's 16, so that's 0.1 moles. Now, because we know that one of these gives one of those, 2 would give 2, 5, 5, 10, 10, 0.1, 0.1. Okay, we relate the moles in the equation. So over here, this 0.1 will give me 0.1 moles of CO2. But CO2 weighs something different. And the question asked me, how much? What did it weigh? Okay. In my triangle, grams equals moles times RMM. So grams equals moles times RMM. That equals, well, I know I have 0.1 moles. And RMM, I worked it out, it was 44. And that is 4.4 grams. So that's why it's useful. I know that if I burn 1.6 grams of the methane, I get 4.4 grams of carbon dioxide. Okay? So there are two parts to this. One is understanding that a mole is just a big number like 11. Yeah, I know 11 is not a big number, but what I mean is, you know, like soccer team is 11 people. This atoms are really tiny, so they have many, many in a team. So this big number is 6 with 23 zeros. 23 zeros is a massive number. 600,000 million, massive. We don't worry about that number. We just look at how many there are. So 1 mole, 2 moles, 1 mole, 2 moles. But 1 mole of this weighs 16, 1 mole of this weighs 32, so 2 would weigh 64. 1 weighs 44, 1 weighs 18, so 2 would weigh 2 18s, 36, okay? So that's what we're trying to do. What we are trying to do with this triangle is to link something that we can weigh with the number of moles. Does that help a bit? I hope that helps a little. Okay, cool. Well, you are most welcome, Silver Spring. Thank you very much for asking the question. If this is, when we do some more of this, if there's another problem, you just hang on and we can do some more. Yeah, you just wait for a minute and, you know, when everybody else has gone, and we can do some more. I have recorded all of this lesson anyway. I will put it on YouTube. It takes a couple of hours, but I will put it on to YouTube. I will send it to the supervisors. Then they can show you where it is, and you can just scroll through to what you need to see, okay? But hopefully now it will make a bit more sense. If you go back and you look at the questions, it will make a bit more sense, okay?